Today, we visit one of the sunniest countries in the world, Saudi Arabia, to learn about new research into solar energy.
If we could cover 1% of Earth's surface area with solar cell, that can be sufficient to power all what we need in energy.
So why don't we do that?
The answer is the cost.
We are PhD comics.
And we want to know why.
Oh, wow! Awesome.
Oh God.
These are crystal silicon.
Crystal silicon.
Right. This silicon, it must be pure. We need to heat it until 1000 degrees Celsius, though it is expensive to have a good quality crystal. That's why we need to rethink, to re-engineer, to find a new materials that can be really cost-effective, processed and installed very easily. That's why we are doing research on organic materials,
Organic materials.
polymers,
Polymers.
conductive polymers.
So show me some solar cells. What is this?
It's an organic solar cell made of organic polymers. We start by a substrate. This is a glass substrate. We have what we call ITO, indium tin oxide, which is a transparent electrodes. On top of this, we put what we call the whole transport layer, and it helps the electrons to go outside the device. On top of it, we put the active layer.
Active layer.
Right. So it's a polymer solution, and we dissolve it in an organic solvent, and it becomes like an ink. So we put a droplet on the substrate, and we rotate the substrate to spread it out homogeneously. And we can control this active layer thickness by the rotational speed
Oh, yeah.
and also the concentration of this polymer solution.
Okay.
And on top of it, we put calcium aluminum layer. These are top electrodes.
And the electrodes are basically to carry the electrons, the current, the electricity.
That's true.
Okay.
This is a hard solar cell, glass substrate. And this is on plastic. It's flexible. So you can have it on your backpack, for example, or
Wow. How do you test them?
we use this solar simulator to test
Solar simulator. You
But-
simulate the sun.
it. Exactly. Exactly. So we calibrate the power of the lamp as if it can give us the power of the sun.
Pond5.com.
And we're ready. We're ready to test. What we test is an IV curve, which is a current versus voltage. What I need is the maximum power. The maximum power is the compromise between the current and voltage. And this maximum power point, it will give me the best efficiency that I can have from this device. It's called solar power conversion efficiency.
Solar power conversion efficiency.
Yeah,
Silicon cells, you can get like up to 18 to 25%.
that's true.
So what can you do now?
In this architecture, we can have up till 8.5% power conversion efficiency
Okay.
in a single cell.
Almost halfway there.
Right.
Okay.
That's why we are all rethinking, re-engineering the device. This science is gathering chemists and physics and material scientists and also electrical engineers, mechanical engineers.
Oh, wow.
They are all thinking about this problem.
Because it's going to release us from fossil fuels.
That's true.
Wow, let's hope that it works.
Oh.
Make it happen.
All right.
Yeah. So this is so cool. So you have material that's in the water, microbes, and it eats the organic material that's already in the water because it's wastewater.
Exactly.
And then it uses that to create electrons, which when you create electrons and then they move, that's electricity, it's energy.
Exactly.
Awesome, okay. So